So welcome again, right? So we're gonna go straight to the corrections of that. So the first question that we had is this one, and then this question gave some of us a bit of a challenge, right? So let's look at how to deal with it. So here you are given an arithmetic and a geometric sequence which were combined to form the pattern. So which means your pattern is made up of an arithmetic sequence and a geometric. So you have to check which one is making up the arithmetic and then which one is making the geometric. If you check x, 2x and 3x, that is the arithmetic part, okay? So x, 2x and 3x, that is the arithmetic part. We'll just write arithmetic. And then now the geometric part is made up of 1 over 3, 1 over 9 and 1 over 27. Okay, so 1 over 3, 1 over 9 and 1 over 27 makes up the geometric part. Now why am I saying that the first one is arithmetic and then the second one is geometric? This is because now if I were to write x, 2x, 3x, remember to check whether something is arithmetic, I would have to say 2x minus x, which is t2 minus t1. Well, 2x minus x gives me x, while 3x minus 2x, remember just look at two numbers that are following each other, then you say the one on the right minus the one on the left. So 3x minus 2x should give me 1x. I always say to grade 9s, I'm like, grade 9s, if you have 3 x's, of course they don't understand what is an x in life, but I believe an x is someone you once used to do some stuff with, right? So if you have 3 x's and then you remove 2 x's from there, you are left with only 1x. So from there, that tells you that this number is constant. If it is the same, then this tells you that this is your common difference, right? This is your common difference, and your common difference, if that number is the same, then that is your common difference, which means you are dealing with an arithmetic. So that is why this pattern there is an arithmetic. Then how do we know that the second one is geometric? Remember, it's 1 over 3, we have 1 over 9, and then you have 1 over 27. If I look at two numbers that are following each other, I then just say the one on the left, right, divided by the one on the left. So I say 1 over 9 divided by 1 over 3. The answer there should be what? It should be 1 over 9 times 3 over 1. So the answer should be 1 over 3. Which means to get to the next term, I must multiply by 1 over 3. I do a similar thing there by saying 1 over 27 divided by 1 over 9, and then it further gives me 1 over 3 again. So which means I should multiply by 1 over 3. So since there is a constant ratio, because this is your r, means your r is 1 over 3. That is what you would call your constant ratio. Okay, your constant ratio is 1 over 3. Now since it's 1 over 3, that tells you that your sequence is geometric. Why are we saying it's geometric? Because there is a constant ratio. You are multiplying by the same number to get to the next term, right? You are multiplying by the same number to get to the next term, while here you are adding by the same number, because our difference is x, which means each time to get to the next term you must be adding x, which means it goes like this. You have to say here you add x, x plus x is 2x, and then you add x, 2x plus x is 3x. So since it's like that, for the arithmetic part, the next term would be what? You have to add x, so that the next term is 4x. And then for the geometric part, to get to the next term, you must multiply by 1 over 3, and when you do that, you're gonna get what? What is 27 times 3? 7, 14, 21. I think it's 81. Yeah, I think it's 81. So Then since it's 81, that means the next two terms of the pattern, it goes arithmetic, geometric, arithmetic, geometric, arithmetic, geometric. So the next here is going to be arithmetic, which is going to be the 4x. Let me write it there. So here it's going to be the what? The 4x. And then after that it comes back to be geometric. We know that the next geometric is 1 over 81 there. So that is how we get the next two terms. And then that pattern can go on and on like that. I hope that this is clear. You just have to identify which one is making an arithmetic sequence and then which one is making a geometric. Then from there you say from the arithmetic which one is the next term. Then from the geometric which one is the next term. From that you are able to get your two terms of the pattern, the next two terms of the pattern. Okay, is anyone with a question there? So for questions like this, right, whereby you are told the first term of a geometric, first of all, we have to understand that we're dealing with a geometric. So that means if it's a geometric, we're dealing with A and R, right, which is the ratio and the first term. Remember that the general formula for geometric sequences is Tn is equals to A to the power of, or it's AR to the power of n minus 1. This is the nth term of a geometric. So that would be the nth term or the general term of a geometric. Now from that, now we're given that the first term is 14, which means you're already given that your A is equal to what? To 14. So because of that, you can substitute it inside here and say your Tn is equals to 14 Rn minus 1. That is the first term. And then now you are also given that the sixth term is 448. Good people, this is very, very important. The moment you are given the position, when they say sixth, it means they give you position. Remember, if you see some things like TH, ST, RD, right, etc., or ND, right, these things, they mean that you are given the position, first, third, second, and the likes. Okay, so since here we are given the position, that means you are given n. It means your n is 6, but what you are given is the sixth term is 448, which means, remember, the sixth term means that T6 is equals to 448. If you can remember that. If I say to you the sixth term is 448, then that is what I mean. If I just say the sixth term, it means I just told you that we have a certain T6, but you would just write ARN minus 1. You wouldn't know what is T6, okay, because you would not be given. But if you are given, that's when you substitute that T6 as 448 because you are given. So you put it there, right? Remember, you're already given the position because they said the sixth term. So you're going to say 6 minus 1. So you're going to have 448 equals to AR to the power 5. But then remember that you already have your A. We said our A was what? Our A was 14. Then now we can divide by 14 both sides. If we do that, our R to the power 5 will be equal to 32. Then now to get that R, since is the fifth root, you're gonna find the, since is the power of 5, you're gonna find the fifth root, okay? The fifth root of that, the answer is gonna be 2. Remember guys, if I give you the cube root of 27, to get the answer, you're gonna say, I mean, not the cube root of 27, x cubed is equals to 27. To solve for x, you have to find the cube root of 27 both sides, so that these they cancel. You are left with x is equals to 3. If I say to you the fourth root of 16, right, oh, sorry, x to the power 4 is equals to 16, you have to put the fourth root, okay? So you put the fourth root here, both sides, fourth root. But for even numbers, fourth root, sixth root, eighth root, you put plus or minus. So your x there would be equal to plus or minus 2. Okay, I hope that that is clear. And then now that we have that, the next thing we'll then have to do there is to solve. If maybe you are given, just as another example, let's say I give you p to the power of 6 is equal to maybe how much, let's just say 20. So you'd have to say the 6th root, and then you'd have to say the 6th root, but make sure that you put plus or minus. Okay, make sure that you put plus or minus, because it's an even number. 6 is an even number. Okay, so you put plus or minus, and your answer is gonna be plus or minus whatever is the answer. I hope that is clear. Then we can go further and proceed. So to get the ratio there, that's what you do. So the ratio is 2, guys. Please, if they say the 6th term, the 5th term, the 4th term, that means you are given t something. Remember, we're talking about tn. It means you would have been given the position. Alright, you would have been given the position. I think on the last or previous session, we spent a lot of time on those type of questions. So the PDF is available. If you don't want to go through the lesson, just have to go through the PDF and check the last questions we were doing. They are addressing that. That's why we say we are assessing you on what we have taught you. Alright, so now next question. Right, next question. Now this was a bit of a challenge question, right, which is good, to be exposed to these type of questions. They give you that this thing is an arithmetic. Me now, when I first see that they're saying it's an arithmetic, I don't waste time. I start there by remembering what type of sequence is arithmetic, or what is happening when an arithmetic. Please remember that if you have an arithmetic, you're gonna have 7, you have x, you have y, and then you have negative 11, isn't it? Now, since it's arithmetic, that means if you say since it's arithmetic, that means you are either adding the same number to get to the next term, or you are either subtracting the same number to get to the next term. So that means remember, to get what should be here, you have to say the number on the right minus the one on the left. So you say x minus 7. While here you'd also say y minus x, right? And then while here you'd say negative 11 minus y. It's always the number on the right minus the one on the left on two numbers that are following each other. Okay, so right now here's what we have, right? We don't have much information, but let me tell you something, guys. When you are looking for x and y, two things that are unknown, that should tell you that you have to use simultaneous equations in most cases. So because you have to use simultaneous, you need to have equations that you have, at least two equations. But the question would be, how do I form two equations from the following information? It doesn't seem like it's going to help me much. First of all, why did we do this, guys? It's because, remember, it's an arithmetic. So we say the number on the right minus the one on the left, on the right minus the one on the left, on the right minus the one on the left. It gives us what we must add to get to the next term. But then since it's arithmetic, let's remember that for arithmetic sequences, the common difference is the same. That means this number is actually equal to this one, and of which also is equal to this one. You see, so you can just choose any two pairs. So let's start with the first pair. I'm gonna choose x minus 7 is equals to y minus x. If I have something like this, I can take this negative x to the other side. It's gonna change the sign to say x plus x, and then I can take the negative 7 to this side so that I have y plus 7. That means I'm gonna have 2x is equals to y plus 7. Now I don't know x, I don't know y, but now I can make one of them to be the subject of the formula, because I want to solve for x and y. So I can make one of them to be the subject. I'm going to make y the subject because x will give me some fractions, right? So I'm gonna have to say 2x minus 7 is equal to y, then I'm gonna call it my equation 1. Now I need the second equation. The second equation, to get it, I'm gonna choose these two pairs now, because I started with these two. Now I'm gonna choose these two. So I can say y minus x is equals to negative 11 minus y. I can also take the negative y to the other side, so that I have y plus y, and then I can take the negative x to the other side, so that I have plus x. So that means I'm gonna have 2y is equals to negative 11 plus x. But remember, we already know that y is 2x minus 7, right? So that means where I see y, I can put 2x minus 7, and then this is y there. You see that? This is our y here. That's our y there. So on that y, we're gonna put 2x minus 7. 2x minus 7. Right. Then from there, I can say I have 4x minus 14 is equals to negative 11 plus x. Now please allow me to just finish working on that one, just this side. So now that I have that, I can take the x to the other side, so that I have 4x minus x is equals to negative 11. Then I'll take the negative 14 to the other side. It's going to change the sign to positive 14, so that I have 3x is equals to 3. When I divide by 3 both sides, voila, then I can get my x value. Now I just need to get y. It's easy to get y because we have equation 1. So we can just say y is equals to 2 into 1 minus 7, because the x is here. And we know that x is 1. So that will be negative 5. So in that way, your y will be negative 5, your x will be 1. Then you have solved your question. I know it was a bit of a lot, right? But that's what some of the questions do, guys. They want you to work a bit harder, to sweat a bit harder, right? But you just have to not don't give up on it. Just keep trying it, okay? If you do have any question, please do not be afraid. There is a button there, I think the hand button. You can just press it, and then I'll respond to you, or you can just talk to me. Right, so now that is it there. Next, now we can have what we call we also have another way of solving this thing, by the way, if you prefer maybe this method. Another way you could have solved this is that 7 is the first term, isn't it? Because it's on the first position. Your t number 1, the term in the first position, remember t1 means the term in the first position is 7, or your first term. This means first term. So your first term is 7. That actually means that your a is equals to 7. Since your a is equals to 7 now, look at negative 11. Your negative 11 is what? Your negative 11 is on the 4th position. So your negative 11 here, it's on the 4th position. So your n is equals to 4 here. So you can write it like this, that your t4 is equals to negative 11. That's your 4th term. Now remember, tn is equals to a plus n minus 1d on arithmetic sequences. So that means if I have t4, I know the position, I can say a plus 4 minus 1 and then d. But then I already know a, isn't it? Remember, a is equal to 7. And I also know t4. Remember, t4 is negative 11. So I can say negative 11 is equals to 7 plus 3d. In that way, I can actually find the common difference. I can now say negative 11 plus 7. Remember, when I take the second 7 to that side, changes to negative 7 equals to 3d. Actually, if this question was asked, I would ask you to say find the common difference. Yeah, that would have been more nice, right? Right, because actually here you can find the common difference. So now you can say you have negative 18 is equals to 3d. You divide by 3, you divide by 3, therefore your d is going to be negative 6. So you now have the common difference, you now have the first term, isn't it? Now your x is in which term? The position. X is in position 2. So can we agree that just like I said t4 is negative 11, I can also say t2 is equals to x, because that is what I see there. Now t2, if you were to use this formula again, t2, good people, it's a plus 2 minus 1 and then d, because your n will be 2. So that means you're gonna have t2 is equals to a plus a d. But you know t2. What is t2? It's x. So you write x. And you know your first term. Remember your first term is 7. You write 7. And you know the difference because you just solve for the difference. Your difference is negative 6. And if you put that in your calculator, you get that your x is equals to 1. Wow, what a beautiful way of solving that. Now you know that x is 1. Then now I'm looking for y. It's very simple. Which position is y? Well, y is in t3. So t3 is equals to y because y is the term in the third position. If I were to use again this formula, just highlight it a bit differently so that you can always look at that. Right, this is the formula we're using because it's an arithmetic. So if I were to get t3 using that formula, I would say t3 is equals to a plus n is 3 because it's in position 3, right? And then d. So I'll say t3 is equals to a plus 2d. But don't I know t3? I know t3 is y, isn't it? And then don't I know a? I know a is 7. Don't I know the common difference? I solve for the common difference. It's negative 6. So if you say 7 minus 12, right, as your y, you get that your y is negative 5. What a beautiful way of solving that. And the nice thing is that actually I was doing the same question yesterday with one of my students in this IEB school, right? So he solved it this way, and he's like, say I took this from you. But me now was surprised because I didn't think he would approach it this way. Yeah, but I thought he was gonna go the simultaneous equations method, which is what I also thought. But he proved me wrong. Actually, he used my methods to then create something magnificent. Okay, right, sharp. Something nice is this. All right. So that is how we solve this thing, guys. A lot of ways of killing the cat, but it's very nice to kill the cat when you understand it. Okay. So this is what we have, and then I believe we have done justice in terms of the corrections. This is going to be our culture, right? We write post-session tests, and then after that we do some of the corrections from the questions that were difficult, and then we'll move to the next thing. So the topic of today is now we're gonna move to series. Remember we talked about sequences. Now we're gonna discuss series in detail. And remember the series that we're gonna discuss is there are only two. There are only two. Now remember that we said the series that we have arithmetic, and then we have geometric. We have also a geometric series. So what is a series, by the way? When you talk about a series, I think if you watch movies, right, like right now the fact that Squid Game is coming out this year, right, it's gonna be a beautiful year, guys. I think it's Squid Game, we got Alice in Borderland. If you watch these things, guys, you know, you will understand me when I say that a series is just adding more episodes to a whole franchise, to a whole Yeah, they usually call it franchise. So if maybe I'm talking about Squid Game, you had season 1, you had season 2. If I add a season 3, that means I'm just adding more episodes to Squid Game. So that means a series, we are adding the terms in the pattern. Understand? You are adding the terms in the sequence. So if I had 5, and then I had 7, and then I had 9, and then etc, etc. Now, and then I decide to say I want to add those terms, then now I can write it like this: 5 plus 7. Ooh, wow, didn't we could do that. Sorry. 5 plus 7, and then plus 9, and then plus until infinity. So if I wanted to add all of those terms, then then now I've turned this from being a sequence into now a series. Then you know that, okay, we are adding the terms in that pattern, in that sequence. You are adding them. Why do we add them? Well, in real life, why do we add some of these things? Well, there are a lot of things you can do when you are adding some terms in a sequence, right? But I will get to that when we go into applications of these. So, what do I do when I have to add a sequence? There are main things that you must understand. Number 1, you must identify the type of the series. That is it. You must just have to identify the type of the series. Are you working with arithmetic, or are you working with geometry? You see, are you working with arithmetic, or are you working with geometry? Then number 2, after you have identified the type of series, you then have to say okay, what is your A, and then what is your R, or what is your D, depending on the type of series. Okay, then the other crucial thing now is that what is N, right? What is N? Meaning that how many terms are we adding? That is very crucial. You need to understand to say how many terms are you adding. So those are the 3 steps that you're going to apply on any type of series problem. I do not really care what type of series, like what kind of problem is it. In all of them, you will have to identify what type of series is it. And then in all of them, you have to understand, are you given A, are you given R, are you given D, are you given Sn, and the likes. When do you use Tn? And then what is N? How many terms are you adding? So for us to then maybe demonstrate that, let me say again, I'm gonna take 5 plus 7 plus 9, and then plus. Good people, if I give you something like this, remember I said the first thing to do is to understand, number 1, what type of series are we working with. So it doesn't change, guys. You just still have to say right minus left or right over left. So here, if I say right minus left, I get 7 minus 5 is 2. I get 9 minus 7 is 2. This means I'm working with a what? An arithmetic series. Now, since I know that it's arithmetic, already I then know that the difference is 2, the common difference. Then I already know that the first term is 5. Then the next thing I would want to know is that how many terms am I adding? Now, to know how many terms we're adding, number 1, it can either be given in the question, or number 2, you will have to find out on your own how many terms you must add. Right now, let's assume we're given in the question. So let's just say the question says calculate. You can either say calculate S of 20, or it can say calculate the sum of the first 20 terms. Calculate the sum of the first 20 terms. So how do you calculate that sum? Obviously you would then have to say again, now you know what type of series is it. So because you know the type of series, that will allow you to use the correct formula. Because remember, if you are dealing with a geometric, the sum formula when you have to add the terms is Sn is equals to A into Rn minus 1 all over R minus 1, or it is Sn is equals to A into 1 minus R to the power n divided by 1 minus R. Then when you have to do that for an arithmetic, right, you use the formula Sn is equals to n over 2 into 2a plus n minus 1 d, or you say Sn is equals to n over 2 a plus l. Now you must know how to choose the correct one. So for you to choose the correct sum formula, it depends on the question. If on the question, well, that's why I said first of all get the type of the series. Right now we know that we're dealing with arithmetic, so it means you're gonna focus here. We're not gonna focus here because it's not a geometry. So since you are focusing here, now I have to choose between this one and that one. This one I use it if I know the last term, but here I don't know the last term because the 3 dots means until infinity, right? So I don't know the last term, so I can't use this one. Rather I'll have to use this one. So when I use that one, I'll then say the sum of n is equals to n over 2 2a plus n minus 1d. Now it's important to understand that the n that you see on these sum formulas, this n here, is no more the same as the n that we had when we were talking about Tn. This n is the position of the term, to say where is the term. But now remember that this n is talking about how many terms you are adding. Actually, to put it nicely, it's actually the first number of terms you are adding, but you can just say how many terms you are adding. That is your n there. Right. So now that we know that, n here would be those 20 terms that we are adding. So you say sum of 20 terms. S20 means the sum of 20 terms would be 20 divided by 2 into 2. What is your first term? You see, that's why it's important to identify your A and D. So your first term is 5, and then remember you are adding 20 terms, and then your difference is 2. Then from this you can put it in your calculator and get the answer. What should be the answer there? If you have a calculator, can you please assist me? So we get the answer as 408, which is great. So that is the sum of your first 20 terms. Good. Not that difficult, right? Let's keep going and try some more examples. So let's say we got ourselves 6 plus 10, or maybe let's make it decreasing this time. 10 plus 6 plus 2, and then plus, oh okay, it's fine, plus others until infinity. So here we are, right? We got a series. How do we know it's a series? Because we are adding the terms, so we know definitely it's a series, not a sequence. Now since it's a series, we have to identify, is it an arithmetic series or is it a geometric series? So for you to do that, you can, it's trial and error. So I'm gonna check whether it's arithmetic first, so to check whether it's arithmetic, I would say here 6 minus 10. 6 minus 10 gives me -4. Then I say 2 minus 6, right? 2 minus 6, the answer is -4. So I write it there. So because the number that I'm subtracting with is the same, this means we're dealing with an arithmetic series. Now that we have an arithmetic series, we can then say our A is 10, our difference is -4, right? So let's say we're told that calculate as the question, right? The question says calculate the sum of the 60 terms, right? So to get the sum of the first 60 terms, we know that the fact that they want the sum of 60 terms, that means they are looking for S60. So it's arithmetic. Now I have to choose between those two formulas for arithmetic, remember. But here I don't know the last term because it says add until infinity. So I'm just going to use the normal one we used before, which is n over 2 and then 2a plus n minus 1d. So I'm looking for the sum of 60. I'll just say 60 divided by 2, then 2 into 6. Oh, the first term, remember, is 10. So I have to substitute 10 there. And then n is going to be 60. Right? And then my difference is going to be -4. Right, so what do we get then? We get -6,480. Like this, right?
Yeah.
Great. So true, that is how we do it now. So now let's then move on to maybe some of the geometric. Remember, geometric and arithmetic, the procedures are very much similar. Okay, so let's say now we are given 1 over 3 plus 1 over 9 plus 1 over 27. Oh wait, sorry, just before I go to this one, what if we have something like this? This one. So we're given an arithmetic series here, and now we need the sum of the first 20 terms of the actually this is series, it was supposed to say series, not sequence. Series here. Right, let's say you're given something like this. Is there anyone maybe who can tell me how they would approach this to get the sum? Yes?
I think you first solve for A and B.
First of all, A and B. How can we do that,
Yeah.
Sam?
T2 minus T1 is equals to, something like that.
Is equals to?
Is equals to T3 minus T2.
Okay. T2, the second term I believe is 13. First one I believe is A, and then the third one I believe is B. The second one I believe is 13. Then how do we get A and B?
So you first make one of them the subject. You can make B the subject or choose between B and A.
B, okay. So I can say 13, then I'll take the -13 to the other side to become positive 13, and then I have minus A. So I find myself with 26 minus A is equals to B.
Yes.
Now where to?
And then you say T4 minus T3.
T4 meaning that 1, 2, 3, 4. The fourth term minus T3, okay,
is equals to T3 minus T2.
T3 minus T2, right? So the fourth term is 27, and then the third term is B. The third term is B, and then the second term is 13. So from this, I don't know, say, can we take the negative B to the other side?
Yes, sir.
Alright, so I will take the negative 13 to this side, so that perhaps I have 27 plus 13 being equal to 2b. Now this, if I put it there, I'm gonna have 13 40, so I have 40 is equals to 2b. Therefore from there I can get that my b is actually 20. Now that I have b, we can substitute it there, right? Now we can say 26 minus a is equals to 20. So I can take the 20 to this side and then bring the negative a to that side, so that I have 26 minus 20 equals to a. So your a is going to be 6. Are you happy with this one, sir?
Yes, sir.
Perfect. So now we have our a and b, which means actually we can have the sequence. Yeah, we have the sequence. Then what is next, sir?
Now you determine the A, the D, and also the number of terms.
Okay, perfect. So now, therefore, this means our a is 6. The difference there, the common difference would be what? What is 13 minus 6? Remember, as the sequence, it would be like this. You would have 6 plus 13 plus 20 plus 27. You must write the sequence first so that you identify your d. So what would be 13 minus 6?
7.
That would be 7. And then 20 minus 13 is 7. 27 minus 27. Perfect. So this should give us our d to be 7. Ne? 7. So now we need our n is 20, because we have to get the sum of the 20 terms. So now we can say we can use this formula, n over 2 2a plus n minus 1 d. So now we can say the sum of 20 is equals to 20 over 2 2 into a, which is 6, and then 20 minus 1, and then the difference being 7. So what do you get as the sum of your 20 terms? Perfect. 4,350. Thank you so much, sir. Well done. That is exactly how we find the sum, and then that is how we use this to find the sum. So now some of the questions, right, they will come like this. So this is the first type of questions that you are going to find, okay? And then the other types of the questions that you will get would be in this format. I think I had the following. Right, so some of the questions they can come in this way. I'm showing you this one because I know most of us, when we find that now it's minus minus minus, you feel like now it's something totally new, ne? But actually it's not. Okay, when it's minus minus, it is still a series, even though it doesn't seem like we're adding them. It is actually still a series, but I want you to take that minus something as a term itself, to say this is a term itself, a term itself, and a term itself. So what is actually happening is that you have 2 plus what? You have 2 plus a negative 4, and then you have a plus a negative 10, and then you have a plus a negative 16, and then you have a plus like that, a negative something, but then remember, these are the terms themselves. These are the terms themselves. Now these in the brackets, then what happens that why you are seeing it as a negative here, why it's become a negative, is because we have said positive times negative. Positive times negative should give us what? Negative. So Buana, they already did it for you. That's why you just see minus. They said positive times negative, then they wrote it for you. Positive times negative, then they wrote it for you. That is why you see it like that. So those are the individual terms. So you still then treat it the same way you were treating others. So if I wanted to calculate maybe the sum of 10 here, I would say, all right, what is the difference there? Minus 4 minus 2 gives me what? Minus 6. Okay, and then here minus 10 minus negative 4 gives me what? Minus 6. Okay, gives me minus 6. Same thing here, minus 16 minus negative 10 gives me what? Minus 6. So from this I can say therefore the difference is negative 6, and then your first term is what? Is 2. So from that now we are looking for the sum of 10. Remember, this is the sum of 10, the 10 terms, not the 10th position. So the sum of 10 would be 10 over 2. Then you have 2 into a, which is 2, and then remember you see 10 minus 1, and then your difference is negative 6. Then from there you will get your answer. So that is how you deal with these ones, whereby now you are given that minus, minus, and the likes. So it is still, you take them as the terms themselves, it is still a series. I hope that is good. This is what you deal with when you're dealing with sums, arithmetic sums. But then I also want to show you this, right? Just before we go, yeah. So if I plus 2, right? Let me just have the following 2, right? What if we have something like this?
Is it possible for the sum to be negative? Like negative after you're done calculating everything?
Yes, it's possible because remember you are adding negative terms. So when you add all of these negative terms, the sum is gonna be negative. What do you get?
I got 35, sir.
Here you got 35 when you put it in your calculator.
Yeah.
Okay, no stress. Thank you so much for that. Then let's say you have something like this, good people. When it's like this now, we call it a finite series. This one is a finite series, whereby you know what is the last term that you're going to be adding. You know the last term that you must be adding. So if it is like that, usually they will just say calculate the sum, you see. So when you would have to know how many terms actually are they. So to get that, you need to do a bit of maths, right?
Sir.
Yes.
I first found the common difference. Sir.
You first found the common difference. The way you're saying common difference, it means you already know it's an arithmetic, this one. Yes.
Yeah.
And is it 2?
Yes, sir.
Okay. And then what will be the next step?
I identified my A and my B, my D, my A and my D.
So A is 5 and then D is 2. Okay.
And then I used the formula, the Tn is equals to A plus bracket N minus 1D.
Why?
So I can find out the rule, like the rule of the equation, sir.
The rule.
Yes, something like that, the rule.
I would like to say it's because you didn't have N.
Yes.
In the previous questions, remember, I always gave you N by telling you that I need 20 terms. I need you to calculate sum of 10 terms, 60 terms. But now the case is different here because you don't know how many terms there are, isn't it? So you don't know N. So to get N, indeed, you do check this one. So let me write like you're saying, say N minus 1D, and then what do we substitute?
A 5. A is 5, say, plus bracket n minus 1, and D is 2, say, n minus 1, 2.
Or
No, so you
two.
can put 2 instead of 3. Put 2.
Okay.
You multiply 2 into n minus 1. Therefore, you get 5 plus 2n minus 2.
Great.
So, so Tn, the nth term, is equals to 2n plus 3.
2n plus 3. Okay, yeah. Now you got the general terms, eh? Then what?
So after that, I found out which term is equals to 21.
So we
I
wanted
found out the
to,
term is 21.
which term is equals to 21, meaning that in which position does 21 lie? Remember that 21 is the last term there. Do you agree with me, sir?
Yes, sir.
It is the last term. So if we can find the position, of that last term, that will actually tell us how many terms there are. Because, for example, if you are the last born at your home, and then you say I'm the 7th person at home and I'm the last born, it means how many are you at home? You are 7, because you are the last born. So if the last born is the 8th, it means at home there are 8. If the last born is the 9th, at home there are 9. So in this case, the last term is 21. So if you can find the position of 21, that will tell us the n, how many terms there are. So to get the position, like you said, substitute 21 here, because we know the term, but we don't know n, which is its position. So I believe we say 21 minus 3 equals to 2n, which would be 18 equals to 2n, giving you that your n is equals to 9. That means the position of this one here is 9, which means even here there will be 9 terms. Then that's when now you can calculate the sum, because now know the number of terms. So now you can say the sum of those 9 terms. Remember, S of n, which formula did you choose then?
I chose S of n is equals to n over 2, bracket a plus l, close bracket.
A plus L. Why this one?
So you said that if we are given the last term, we can just put it there. So I'll get the last term, which was 21. So I just plugged it in.
Perfect. But it is the sum of how many terms that we're looking for?
Sum of 9 terms.
So we do write that we are looking for the sum of 9 terms, which would be 9 over 2, and then A will be the first term, which is 5, while L will be the last term, which is 21. Great. So if you are given the last term, you can just simply put it. So now that sum of 9 terms would be what? It is 26 here. Divide by 2 is 30 times 9. Oh, what is the answer?
117.
Great. Thank you so much, sir. So exactly that is how you do it, and that is how you get the sum in that series there, right? So this is questions where you're given the last term. Let's say that you are given the following. Another example related to that would be, let's say you are given 20 minus 10 minus 40 minus brackets and then minus 490. Right? How would we get the sum for that? So like we did in the previous one, and like what Fatai did, he first of all found the difference. So he said negative 10 minus that. Even though it's negatives, you don't say 10 minus 20. No, Remember I said you take this as a term, right? So you're gonna say from here to there, you're gonna say negative 10 minus the 20. So the answer you're gonna get is negative 30. Then when you come from this one to that, you say negative 40. You take it as a term minus the negative 10. You take it as a term, and don't forget to use brackets. I believe the answer you should get is also negative 30. And therefore that will tell you that your first term is 20, your difference is negative 30. And because you have those two crucial things now, you can be able to get the sum. But then now you need to know how many terms are we supposed to add here. To get the terms, you need to find the position of this guy. If you can get the position here, then that will tell you how many terms you need. But doesn't mean that n is always the same as this n. No, guys. It's just only on this case. So for us to get the position of this, we need to use the arithmetic formula, the general form. And then we say we're looking for where negative 490 is. We know that we're given the term, but we do not know the Tn. So what you simply do is that you write negative 490 here, because that is the term. The first term is 20, right? So you write 20 there. You do not know n, which is what you call, which is the position, and then you know that the difference is negative 30. So this is what you can also do, Mr. Fatai, to save you time from doing that. It's gonna be a lot of steps, but here you can do it in one step. Okay, so now that you would have this, I advise you to take the 20 to this side, so that you have negative 490 minus the 20 is equals to n minus 1 into negative 30. When you reach here, right, instead of multiplying inside negative 30 times that, negative 30 times that, I can advise you to just divide by negative 30. Just divide by the number that will be there. So you do that both sides, so that this and that they cancel, and then you can get the answer here. Not sure what would be what would be the answer, but then it's negative 490 and then minus 20, then you divide that by minus 30, so you're gonna have 17 is equals to n minus 1, because n minus 1 will be left. Then you take the 1 to the other side, you get your n as 18. Okay, get your n as 18. So that means this is in the 18th position, which tells you that we're gonna be adding how many terms? We're gonna be adding 18 terms. Okay, we're gonna be adding 18 terms. Then from there you can go to the sum formula. So remember, now you can say the sum of 18 terms would be equal to 18 over 2. The first term is 20, the last term is negative 490. Right, then you can put that in your calculator to have that 18 over 2, and then what you call, you have 20 plus negative 490, then that should give you negative 4,230. I think from this, Mr. Fata, you can see that you can get negative as your sum. Okay, so that's what you get there. Right, good people, whatever we did then also applies to geometric. Okay, so that is when you are given what you call what, that's when you are looking for the sum, but by first finding the last term first, or you're looking for the sum while they told you that we need 20 terms or to add 30 terms and the likes. So that is it for this lesson, right? This is the sum of an arithmetic, which is also working similarly to the sum of geometric. So we're gonna give you questions, a test, online test, and then from that post-session test, which you can get latest by tomorrow morning. Yeah? Then from there you will answer it. On our next session, we'll be looking at more complex problems regarding this, including including sigma notation. Then from the series they should be easier to tackle.